All right, this is a voiceover for lessons 5.4.2 and 5.6.3. The audio didn't record with the camera device, so just doing this after the fact. So bear with me. So looking at this, basically, we are finding relationships between sides that are created when we have proportionality between two triangles. The specific ones here are when we have an angle bisector. So an angle bisector basically divides the angle in half, and it creates a relationship between the opposite sides and the two legs on each side. The triangle midsegment theorem is a special relationship between the midsegment, which is found at the midpoint of two sides. The midsegment and the third side have a relationship where the midsegment is half as long. So some things we have to remember before we start are that parallel lines have these symbols connected to them. So they have the two lines, or they'll have the two arrow marks on the lines which show that those two lines are parallel. And all that means is a parallel line is equal distance from each other at every point, and also that they never touch. All right, so to start, we're looking at the triangle proportionality theorem. And what this is saying is that lines that are parallel to one side divide the sides proportionally. So we're talking about creating two similar triangles based on the parallel line that intersects with the triangle. So what we can see here is that on the left side, BD, we're going to create a ratio of BD over DA, and then that's equal to a ratio of BE over EC. So you can see that really what we're doing is comparing the segments of the triangle that are split by that dividing line there. So the line DE, or the line that contains the segment DE, splits the triangle up, and basically what we end up with are a proportionality problem. So two ratios equal to each other, we'll cross multiply and solve. So here in the example problem, we have the triangle divided by our line there, and what we create are proportionalities. One of the ratios is 5 over 15, so that comes from the left side. Because these lines are parallel, denoted by these arrow marks, we know that triangle proportionality theorem works. So we have 5 over 15. The other ratio that we're going to create is going to be from the other side. So we'll end up with x over 9. It's kind of hard to see, but it's x over 9. So now that we have our two ratios set up, we have a proportional relationship here. Because we know the theorem helps us know that, what we need to do is cross multiply and solve. So I think I'm going to do that in a moment. Cross multiply, we'll end up with 15x is equal to 45. So again, in geometry, it's always about how the sides relate, how they're similar or relate, and we just relate the values or expressions in the same exact way. So here we cross multiplied 15x is equal to 45, divide by 15, we get x is equal to 3. So I do skip some steps in these videos now here at the end of the year, but I hope you can follow along, and it's actually to help you kind of guess and remember how I got between each step. So here we were asked to find x. We found that x is 3. So based on what we know about the triangle and those parallel lines, our proportionality theorem allowed us to find the answer. All right. So next we are looking at triangle angle bisector theorem. So we are, there we go. Okay, so we have our theorem, and again, the theorem shows the rules of how the sides of a triangle interact. And all we have to do is relate those expressions or values in the same way. So here, if you look at the angle bisector, we know that a bisection is cutting it exactly in half. So we look at that angle B, and angle B is cut exactly in half by that angle bisector. So bisector means cut in half. Angle bisector just cuts the angle in half. So if we look at that, the opposite sides are divided into segments that are proportional to the other sides in the triangle. So what this basically means is we can drop an angle bisector and then create a proportionality problem, just like all the others here. Proportionality problem between the segments. So what I'm going to do is I'm going to relate AD and DC, make one ratio between those two segments. And then I'm going to relate AB and BC. So the key is that the values that are on the top of each of those ratios, AD and BA, the values on the top have to come from the same triangle. You see that it's from the segmented left side. And the denominators of those proportions, DC and BC, come from the right side of that divided triangle. So now to apply it, again, it's always applying the same way that the sides interact and relate. We're applying it to values and expressions that are assigned to each of those segments. So here we create a proportion problem with two ratios. And if we look at this, we're going to go ahead and take what sides? What sides are we going to relate? So think of the angle bisector theorem. And looking at that, we're going to relate x plus 2 and x plus 1. Now, what's nice about this theorem is that you can relate any two sides as long as it's consistent. So I could have related the 7 AB value, 7 and x plus 2. I could make a ratio just of those two values because they're from the left side of that bisected triangle. I would then make 5 and x plus 1 the other ratio. So that's one option, but the option I'm going to show you, and you can use either option, is to make one of them relating the bases that have been split and the other relating the sides. And notice I put x plus 2 and 7 on the top. The numerators are x plus 2 and 7 because those come from the left side of the triangle. Cross multiply, and it looks like I'm probably going to just distribute. Let's see what I do. Oh, I'm just saying why the top values have to be set up in that order. Basically, however you set it up, you just have to keep it in the same configuration. Don't have any logic that doesn't work there. So if you're relating left to right, you have to on the bottom relate left to right, and so on. So there I just distributed 5 times x plus 2 is 5x plus 10, and then 7 times x plus 1 is 7x plus 7. And I moved the 5x to the right, moved that 7 to the left, I end up with 2x is equal to 3. And then I'm just going to divide by 2 and get 1.5. Right? So we're just isolating x. Once you get the proportion set up, it's the exact same thing we've been doing this whole time. It's just relating the sides in the same way that the figure and diagram relate those sides. So here we get x value, but we needed to find what those bottom lengths are. So that's where I go back in and have the 1.5, which is x, and I add it to 2 to get the left segment. 1.5 plus 1, add them to get the right segment. All right. So next, we're going to look at the triangle midsegment theorem. And notice the tick marks on this. The tick marks tell you everything you need to know. If it was just that triangle, and that was all we had, we would be able to figure out this theorem from the tick marks. So basically, what you're looking at here is that side AB, we couldn't find the links we want, but we could deduce the theorem, or at least know how we arrived at that theorem based on those tick marks. So the mid-segment is, you can think of it as midway down the triangle. The way I know it's midway is there's tick marks on the left side. See, AB is divided in half. We have the tick marks on both sides of the x. That shows that it's halfway down AB. We know that point Y is halfway between B and C because of those double tick marks on each side of it. See, those tick marks show me that those two segments in particular are exactly the same. So Y has two segments on each side that are exactly the same because y is right in the middle. It's the mid segment between B and C. It's the midpoint between B and C and the endpoint of our mid segment. So xy is our mid segment. And the basics of this are that the mid segment is exactly half as big as the third side. So if you know that the third side AC was 10, then you know that the mid segment is 5. If AC was 100, the mid segment is 50. If AC is 1,000, the mid segment is 500. So you always know that mid segment is exactly half as long as the third leg. So I know that XY is the mid segment based on the tick marks. So now all I have to do is apply this idea to a problem with values there in the mid segment and the third leg. So let's go ahead and look at that example. It looks like in that example I forgot to put any values in there. So I'll probably throw in some values right now. Let's see. No, I'm doing something else. All right, I'm finding the mid segment of this with this triangle. And I know that, let's say that halfway down that left side of the triangle is a midpoint. And halfway down the other side of the triangle, there's a midpoint. The mid segment is created by the halfway points on each side. See, I put the tick marks. So the tick marks show that the endpoint of that segment is right in between, is right cut in half. So if the third leg is 8, the mid segment's 4. It's basic. It's just half as big. It's half as long. So any value that that third leg equals, you divide it in 2, and that's your mid segment. All right, so now I need to find xy, and I hope I figure out pretty soon that I need some values in there. Don't worry, it's just right now a diagram. You can't find anything. It's because I forgot to put these numbers in. I got 12. Let's say at the third leg. That's probably what we want to find. Yeah. Okay, so don't be confused with this. If you rotate a triangle, you'll be able to find 3 mid-segments. Here, the triangle's just been divided by 2 different mid-segments. So you can see that if AE is the third leg, then the mid-segment is XY. And here the third leg here, AC, is 12. So what did we know about the mid-segment? It's how it's the same. Is it bigger? Is it smaller? What is it? And this is where, if you look at shapes, you can kind of tell which one's bigger or not. You don't want to always use that. But this one's obvious, and it always makes sense this way. The mid-segment is always smaller than the third leg. The mid-segment's always half as big as the third leg. So if that is 12 AC on the bottom, then our mid-segment is 6. So I know this because 6 is half of 12. All right. Next. Next we have the third leg over here. We just look at it rotated. The third leg is BC. The mid-segment is then XZ. So you see here, I know instead that the mid-segment was 5. So I know my third leg BC, that's 10. Okay. So that's all there is to it. Sorry for the glare, but it says find BC, and BC is 10 because my mid-segment was 5. So here's AB. We're going to find the midpoint between them. I wish that glare wasn't there. All right, so we go down halfway, find the midpoint. We go on the other segment, we find the midpoint. Just to be able to draw these, if we really wanted to know the midpoint coordinate, we'd use the midpoint formula. So we know that the mid-segment is parallel with the third leg, and what else am I going to do with this? I'm going to call this 22, and I'm going to figure out what is that mid-segment. So if that's 22, what is my mid-segment? My mid-segment is half as long as the third leg. So all I need to do is divide it in two. Again, so if that mid-segment of the last problem I just wrote with 22 as a third leg, if that mid-segment had an expression, if the expression was x plus 2, then all I would do is make x plus 2 multiplied by 2, and that equals 22. I have no idea what I'm doing now. So that's it. Thanks. Bye.